This is the Vulnerability Discovery Manager tool, VDM, a software component that can work as a standalone tool or as a combined solution that identifies, analyzes, and reports vulnerabilities detected in the target infrastructure with a particular focus on health data, healthcare information systems, and medical devices. The main role of the VDM includes the discovery and identification of vulnerabilities to the system assets, the assessment of the discovered vulnerabilities, the treatment of vulnerabilities that exceed acceptable levels, and intelligence sharing functionalities with other hospitals and communities. VDM has four main components: a vulnerability scanner aiming at discovering the vulnerabilities in every asset composing the target system, a vulnerability storage used to store reports and information about the detected vulnerabilities, a vulnerability assessment aiming at classifying, assigning priorities, and treatments to all detected vulnerabilities, and a vulnerability reporting and intelligence sharing, focusing on generating a vulnerability report that can be shared among organizations. In CUREX, VDM receives input from ADT and obtains vulnerability information from external databases like the Common Vulnerability and Exposure (CVE). Discovered vulnerabilities are stored in the VDM database and enriched with 0-days vulnerabilities provided by the KIA component. VDM shares the generated vulnerability report with TA, CAT, and PAT that use this as an input for their processes. Vulnerability reports are displayed in the VDM dashboard and in the CUREX visualization tool CVT. The main innovative features of the VDM tool are the following: the use of artificial intelligence to discover unknown vulnerabilities provided by KIA, an optimized scanning process based on the system's changes detected by the ADT, an optional sharing mechanism using the sticks format to support and share vulnerabilities among healthcare organizations, an improvement in the threat intelligence analysis process performed by TA, a refinement of the cybersecurity and privacy risk analysis performed by CAT and PAT, respectively, based on the detected system vulnerabilities, and an enrichment of the VDM database through vulnerability feeds coming from open source platforms like MINSP and the KIA component. The VDM needs as input the identification of the assets composing the target infrastructure. The discovery of the assets in CUREX is performed by the ADT. Every time a new asset is discovered by the ADT, or whenever there is a change in the system's configuration, a vulnerability analysis will be performed by the VDM. For each of these cases, the ADT sends a JSON file to the VDM with the IP address, MAC number, and a flag indicating there is a new asset discovered in the system. The VDM tool produces a vulnerability report with valuable information about the target, network, hosts, and their associated vulnerabilities. The report can be displayed in a dashboard or exported in JSON or a sticks format. Now, let's see a real demonstration of the VDM. Before using the VDM, we need to initialize the tool by running the VDM agent command. This allows to start the agent, the ADT manager, VDM manager, and the sticks manager. Once the VDM internal components are initialized, input data coming from ADT can be processed. The JSON file received from the ADT contains the detected assets from the target system and specifies the type of change, IP addresses, MAC addresses, operating systems, and complementary information such as ports, protocols, services, etc. Not all of this information will be used by VDM. Therefore, the tool transforms this file into a reduced JSON file containing only the required input data, such as IP addresses. For this demonstration, VDM is deployed in the Atos infrastructure and will analyze two internal servers with IPs 10.0.2.6 and 10.0.2.7. We use the post-scan command as an ADT simulator to launch the vulnerability discovery process. A confirmation message is generated to indicate the ADT data has been received. In this window, you can see the input data received from the ADT, including the IP addresses of the two target assets. One thread is created for each asset to be analyzed. A confirmation message is generated indicating that the vulnerability manager is ready and connected to a given port. Once the VDM analysis is launched, you can check the elements created in the VDM database. In the ADT specification table, one thread has been created for each scanned IP. In the VDM specification table, you can check the current status of the scan. In this case, two full and fast scans has been launched in parallel and they appear as pending. Once the scan is completed, a message is generated indicating the end of the vulnerability scanning for the target devices. This can also be checked in the VDM database, where the state should be updated as completed. A STIX vulnerability object is created with the VDM report scan, which can be further shared with other CUREX components such as KIA. KIA will update the VDM database with new discovered vulnerabilities. An example of a JSON file containing a remote code execution vulnerability is also available to be shared with open source intelligence platforms like MISP. Intelligence sharing is another functionality of the VDM tool. For this purpose, you need to launch the sharing process from VDM to MISP by specifying the IP of the target machine. In this example, we will use 172.21.40.4. Then you need to launch the conversion of the VDM report into the STIX format using the builder command. And then you can view the created STIX object based on the detected vulnerability in the command line or in the MISP platform. You can check the CAPEX associated to the vulnerability and a description of the potential threat. However, for an enriched visual representation of these outcomes, you can directly connect to the MISP platform. Connecting to MISP, you can check the list of all published events, those you have published and those other communities have shared with you. Clicking on the view icon of a particular event allows you to have access to detailed information about the vulnerability. For this demonstration, we access the remote code execution vulnerability previously discovered by the VDM. MISP allows you to have information about the object creation date, owner, threat level, and distribution. In this case, this information is only seen by you and your organization. However, it can be shared with other organizations, communities, and groups. You have the possibility to share all or limited to share only the attributes or object attributes to the stakeholders you wish to share your data with. MISP also allows to display information about the different common attack patterns and enumeration classification CAPEX associated to this vulnerability object. Information about the CVE, description of the vulnerability, the CVSS impact, and the source of this data is also available in the platform. In this demonstration, our source tool is a VDM from CUREX.